Welcome to Part 3 of Bio-Rad's Risk Calculator training. The Risk Calculator generates a risk assessment report. This series of videos explains the different elements of that report. This video covers the concept of the expected number of unreliable final results reported due to the occurrence of an out-of-control condition, which we refer to as ENUF, or enough. Let's return to our hypothetical lab from the previous video. Again, each vertical line represents patient testing. The test tubes represent the QC events. A green test tube indicates that the QCs were accepted. During the testing, an out-of-control condition occurs that affects all subsequent results. In this example, the first two QC events subsequent to the out-of-control condition failed to detect it, but the third QC event gave a QC rule rejection, denoted by the red test tube. During the time that the test system was out of control, 3 patient results had measurement errors that exceeded the quality requirement, denoted by the red asterisks. 2 of the unreliable results occurred prior to the last accepted QC, and 1 unreliable result occurred since the last accepted QC. The patient results produced since the last accepted QC are the most recent and should be corrected if there is a problem. Results produced prior to the last accepted QC are unlikely to ever be changed and can be considered final. In this example, there is 1 correctable unreliable result and 2 final unreliable results. This video will focus on predicting the expected number of unreliable final results, enough. The number of unreliable final results depends on the QC strategy, test method performance relative to the allowable total error specification, TEA, and the size of the out-of-control condition. The QC strategy is the QC rule, number of QCs evaluated, and number of analyte examinations between QCs, NB. Test method performance is the test method's bias and imprecision. Suppose a lab is using a 1-3S, 2-2S, R-4S rule with 2 QCs every 50 analyte examinations, and the lab's bias is 0, the test method's CV is 1.4%, and the TEA is 4.5%. An out-of-control condition resulting in a 2.2% shift upward occurs. In this case, it can be predicted that the expected number of unreliable results produced during the out-of-control condition, but prior to the last accepted QC, is 8.9. The predicted enough is based on fairly advanced mathematical computations that won't be covered here. Different magnitudes of out-of-control conditions will be associated with different enough values, so we need to look at a range of possible out-of-control conditions. Let's plot our current value. The x-axis represents the magnitude of the out-of-control condition. The y-axis represents the enough. In this example, the y-axis is 0 to 10. For an out-of-control condition of 2.2%, the predicted enough is 8.9. Let's look at a larger out-of-control condition. With a larger out-of-control condition, say a 4.5% shift upward, we would expect a larger percentage of unreliable results, but fewer QC events before detecting the out-of-control condition. As a result, in this particular case, the predicted enough is lower at 1.34. Let's plot the enough for this out-of-control condition. Let's look at a large negative out-of-control condition, say an 8.7% shift downward. In this case, a very large percentage of results are unreliable, but the QC strategy will almost always detect the out-of-control condition at the first opportunity. Consequently, there is little chance of unreliable results occurring prior to the last accepted QC, and the predicted enough is less than 1. Let's plot the enough for this out-of-control condition. We could continue to compute and plot the predicted enough over a range of possible out-of-control conditions, producing a curve. In this case, the curve shows the expected number of unreliable final results for a lab using a 1-3S, 2-2S, R-4S rule, with 2 QCs every 50 analyte examinations and an allowable total error requirement of 4.5%. One way to characterize the patient risk implications of a QC strategy is to determine the maximum predicted value for enough. If the maximum enough is acceptable to the lab, then no matter what size of out-of-control condition might occur, the expected number of unreliable final results will be tolerable. This enough curve appears here on the risk assessment report. We hope you've found this tutorial helpful. Continue your training by viewing Part 4.